Chapter 4, Section 4, Everyday Forces. We've thus far discussed Newton's three laws, and we're ready to start talking about applications of those laws to a greater extent. The first one we'll talk about is weight. And weight is the force of gravity acting on an object's mass. Weight and mass are very much different. Weight is the force of gravity. Mass is mass. Mass is the amount of matter an object contains. More on that later. Second is normal force, and we will talk a great deal about normal force in the upcoming days. Normal force is a support force of any surface on an object. Force N, normal force, is always perpendicular to a surface. So if you're flat on the ground, it's straight up in the air. If you're on a hillside, it's up at an angle, perpendicular to the hillside. If you're leaning on the chalkboard, normal force is coming out of the chalkboard. If you're pushing up on the ceiling, normal force comes down out of the ceiling. It's always perpendicular to the surface, and a vast majority of our examples will be flat on the ground. Static friction. As mentioned a little bit earlier, static friction is the friction between two stationary objects, and kinetic friction is the friction between two moving objects. Look at the physics words, the science words rather. Static meaning still, not moving, and kinetic meaning moving. And that'll help you sort the two out. So more on this whole mass and weight thing. I'd like you to figure out who is heavier, Bob or Robert. Bob has a mass of 100 kilograms. Robert has a weight, force of gravity, of 790 newtons. You very quickly use Newton's second law, force equals mass times acceleration, and figure out the weight, I guess, of Bob or the mass of Robert. Go ahead. Get your calculator out. Just get it out. Divide this. Divide that. Okay, your calculation should show that you took 100 kilograms times 9.81, and you found Bob's weight to be 981 newtons. Bob is therefore heavier than Robert. The reason we bring this up, the words mass and weight are often confused with one another. Mass is a fundamental thing. Mass depends on how much matter you contain. If Bob and Robert were astronauts and they went up into space, Bob's mass would definitely still be 100 kilograms when he got to the moon or to Mars. Robert's weight, however, would not be 970 newtons. It would be 90-something kilograms, but it would not be 970 newtons. His weight would be significantly less on the moon. It's roughly 1/6 of that on the moon. Mars, it's more. The big deal, you have the same amount of mass with you no matter where you go, but your weight changes depending on the gravitational pull where you're at. Okay, mass and weight, big difference. More on friction, if you will, if you please. So, friction. The difference between kinetic and static friction. Friction is caused by bonds between two surfaces in contact. Believe it or not, your atoms on the surface of your hand are trading electrons with the atoms of your pen. Kind of crazy to think about it that way. They're just trading electrons. Nothing too dramatic here, but just an electron here and there. In static friction, the bonds are stronger because the objects are not moving. Imagine you're riding the Gemini in that cool part of the roller coaster where you can give the other people a 5. It would be way easier to reach across and slap hands with the person in the other coaster if you're not moving. It's not a moving target, no problem. Yeah, give me 5. Well then, in kinetic friction, the bonds cannot form as well because the objects are moving. This is what makes it fun to do that during the roller coaster, because you are moving. and so is the other car at different speeds. And because of that, it's hard to give the other people 5. So because they're moving, the bonds are weaker. Because they're not weaker, but they don't form as quickly. Okay? Because they're not moving, they form better. Thus, static friction is stronger than kinetic friction. Interesting, huh? Now, friction itself has a lot to do with the two surfaces that are in contact. Okay, for example, if you have a piece of wood and you put a piece of sandpaper on it, the sandpaper, compared to just another piece of wood, for example, would have a much greater amount of friction. Okay, we'll talk about that right here. Calculating friction. Friction force can be found by multiplying the coefficient of friction for a surface by the normal force exerted on that surface by an object. So, this formula right here, pay attention to this one first. The force of friction is equal to the coefficient of friction times normal force. Now you'll notice that these formulas are exactly the same, because they are. The force of static friction is equal to the coefficient of static friction times normal force. The force of kinetic friction is equal to the coefficient of kinetic friction times normal force. They are the same equation, folks. The difference is, are you talking about static or are you talking about kinetic? Now let's talk about this coefficient. You know how I just mentioned the sandpaper thing? Well, sandpaper on wood would have a greater coefficient of friction than wood on wood. That's why it's more frictiony. That's right, frictiony. Frictiony is a measure of how much friction you get between two surfaces. If two surfaces are more frictiony, their coefficients of friction will be greater. Another example, those of you who are into skiing, people have a tendency to wax their snowboard or their skis. This wax decreases the coefficient of friction between your skis and the snow. By decreasing the coefficient of friction, you go faster. There's less friction, there's less resistance. You go faster. You hit a tree harder. This is why I don't ski. Let's look at an example. We have a crate. The crate, we would read in the example, it takes 75 newtons to make the crate move. Okay? That is the maximum static friction force. Then when they say it takes 75 newtons to get it moving. We know the mass of this crate is 24 kilograms. What is the coefficient of friction between the crate and the surface that it is on? Well, here's where we have to do a little thinking. In this equation, there's nothing about mass. That's a problem. Well, normal force, in this example, is going to be our equal and opposite force to the force of gravity. It's the support force of the ground. Normal force, force of gravity. They're going to be equal and opposite. Because there's nothing pushing down on it, there's nothing lifting up on it to change that support force. Okay, so just trust me, in this example, normal force and force of gravity are equal. Well, force of gravity, the weight of the object, is mass times the acceleration of gravity on Earth. So you're going to take your 24 kilograms times 9.81. That's going to be equal to normal force. So it's going to be slightly less than 240. Goes here. Oh, I'm sorry, here. The friction force of 75 newtons goes there. You're going to calculate the force of static friction. I'm sorry, the coefficient of static friction. In your book there is a little table of examples of coefficients of friction. You will find it useful in your assignment because you'll have to look it up. Oh, steel on wood or glass on steel or something like that. Okay? Just take a second when you're going over the problems. If they give you a mass, you have to do just as we did in this example. Okay? Don't get overwhelmed. You can handle it. Let's turn the page here. And this turkey is going to show us that there's homework, and I do believe it is homework on 139, and it is 1 through 4. Good luck.